So welcome back, and in the last lecture we have seen how we represent any arbitrary periodic waveform as a summation of a DC term or an average value, and so many sums of sinusoidal waveforms starting from fundamental frequency right to the nth frequency, multiple of nth harmonic. Okay, so we can write any arbitrary periodic waveform as an infinite summation from zero frequencies to multiples of the fundamental frequency, or as a sum of so many sinusoids. Okay, so that is what we have seen. We have derived what is how do we calculate a naught, an, and bn, and we have justified that we can truncate the sequence. Even though it is f of t is an Fourier series is an infinite sequence, we can truncate that series at an appropriate point so that it meets our required accuracy. Okay, so that is how we have seen in the last video. And uh, and many times a question arises whether we should find a naught. Is there any need to find a naught, an, and bn for every problems, or is there any situation where bn is 0 or a naught and an are 0? Is there any situation like that, so that we need not unnecessarily calculate a naught, an, and bn for every value? That if we can predetermine that some coefficients, if suppose for some problems, if bn is equal to 0, then why should you calculate bn is equal to 0 if we can predict that beforehand? Okay, or if for some problems a naught and an can be 0, so if you can determine that beforehand, you can determine that, so you can easily solve the problems by simply finding the values of bn, and need not spend time to unnecessarily find a naught and an, which is already 0. Okay, so what are those conditions? How do you predetermine such situations? Okay, so there are certain half wave symmetries, sorry, there are certain symmetry conditions, and I'll discuss around 4 symmetry conditions. And first symmetry condition is actually, that is the if the waveform is even function of time. Already we have seen what is an even signal and odd signal. So what is an even signal? That is, given a signal f of t, that will be equal to f of minus t for all t. That is a peculiarity of an even signal. That is, f of t is equal to minus of f of t for all t. Okay, now here you can see that it is written that we should recall what is f of t. F of t is nothing but a naught plus infinite summation from n is equal to 1 to infinity an cos n omega naught t plus infinite summation from n is equal to 1 to infinity bn sine n omega naught t. Okay, but even function means that f of t has a term associated with sine terms. All sine terms are odd terms, so that will not satisfy this relationship, that is f of t is equal to f of minus t. So straight away you can return this, you can say that all terms associated with time sine terms will cancel or will become 0. Now I have just derived that to show you how bn is equal to 0. Okay, so if that is 0, then bn should be equal to 0. So it is enough to prove bn is equal to 0 for an even function. Okay, so and I have drawn an example of an even function in that figure above. That is, I have shown that is a waveform, a triangular waveform. So at t is equal to 0, it is having the maximum value, but that y-axis act as a mirror, or one side will be the mirror reflection of the other. Okay, so what is happening, what is the value at t naught by 2 will be the value at minus t naught by 2. That is the relationship of f of t is equal to f of minus t. Okay, and what is the value of the waveform at any arbitrary time t will happen at time t is equal to minus t also. Okay, so that is the peculiarity of an even function. Okay, so for even function I have told that all bn terms should be equal to 0. So I'll just prove that. That is, by definition bn is equal to 2 by t naught. I already have made a assumption or statement that all integrations will be conducted for the entire time period. So here I have taken the time period from minus t naught by 2 to t naught by 2 for convenience. So integrating from minus t naught by 2 to t naught by 2, f of t sine n omega naught t dt. Okay, now I'm splitting the integration, so I'm taking 2 by t naught outside, well outside, and splitting the integration from minus one part is minus t naught by 2 to 0. The remaining terms will follow, that is I1, and the second term obviously will be the integration from 0 to t naught by 2, and remaining terms as is actually f of t sine n omega naught t dt. So the first integration from minus t naught by 2 to 0 I take as I1, and the second integration from 0 to t naught by 2 I take as I2. Okay, so it is enough to prove that for Bn to be 0, it is enough to prove that I1 should be equal to minus I2. Oh, okay, so for that I take I1 integration, okay, and I replace the variable the variable, it's a standard integration, the variable of integration was t. I replace that by a dummy variable x, which is defined as x is equal to minus t. X is equal to minus t. Okay, you may wonder why I'm taking x is equal to minus t, because I just want to use the even functionality. That is, what is even functionality? F of t should be equal to f of minus t. So that is why I've taken a dummy variable x which is equal to minus t. And when you substitute a dummy variable, you have to replace everything in terms of that dummy variable. So dt becomes minus dx. So dx is equal to minus dt, or dt is equal to minus dx. So instead of dt in that integration of I1, you can replace that by minus dx. And how do the limits of integration change? That is, initially my integration is from minus, that is, if it was when it was with respect to t, my integration was from minus t naught by 2 to 0. So when t is equal to minus t naught by 2, with the relation of x is equal to minus t, we have that is, if t is equal to minus t naught by 2, my x will be t naught by 2. So so instead of minus t naught by 2, we have t naught by 2. 0 will remain as 0. Okay, so t naught by 2 to 0, that is integration f of, instead of t I can substitute f of minus x sine n omega naught. Instead of t I should substitute minus x, then minus d of minus dx. Okay, and I have two minus signs. Okay, so by virtue of the characteristics of an even function, we have, that is, f of x is anyway an even function, so f of minus x should be equal to f of x. So instead of f of minus x, I can substitute f of x. Okay, and the remaining terms are as such. Now I can take that minus sign outside. Two minus signs are coming, so that becomes positive. But I can change the limits of integration. I can invert the limits of integration by multiplying it with minus sign. So already there were two minus signs inside, it becomes positive, and if I multiply by minus sign, then the integration will be from 0 to t naught by 2. Remaining terms will be f of x sine n omega naught x dx. Okay, now this is a definite integral. So this there the variable was t, here the variable was x. Here the variable is x. So there is no problem in simply replacing the dummy variable x by t. So when I replace that, that should be equal to minus integration from 0 to t naught by 2 f of t sine n omega naught t dt, which is equal to minus I2. So I1 is equal to minus I2. So what happens? My Bn terms will be equal to 0. So if the signal or the function is an even function, I already explained in the very first lecture that a signal is actually a function. So if a signal is an even signal or an even function, a0 and an remain and bn will be equal to 0. That is, all sign terms are absent. That is the first thing you have to understand. That is the first symmetry condition. And similarly, that is for an odd function. So what is an odd function? F of t is equal to minus f of minus t for all t. That is, just see the waveform shown in that document. That is, what is happening at t naught by 2 will the value at t naught by 2 will have negative of that value at minus t naught by 2, or the value at any arbitrary time t will have its negative value at t is equal to minus t. That is the characteristics of an odd function. Sine function is a perfect example of an odd function, and cosine function is a perfect example of an even function. Okay, so here similarly you can prove that, see, a0 is a DC value. DC value means it remains constant whether t is negative or t is positive. So that is an even function, even term. That is, and then an, of course, this is associated with cosine term, so that also is an even term. So both these terms will be absent if the function is odd. So for an odd function or an odd signal, there exists only bn value. So only the sine terms exist, and the dc value as well as the cosine value will get cancelled. Why the dc value will get cancelled? Because for such a waveform, if we take the average value for for a complete half cycle, for a complete cycle, what happens? The average value will be equal to 0, so the dc will be absent. That is why when we take the average value of a sine wave over a complete cycle, it becomes 0. Okay, then we have half wave symmetry. Okay, the third one, that is, what is half wave symmetry? This is very important. This symmetry is very important in electrical systems and especially in electrical machinery. That is, f of t is equal to minus f of t plus t naught by 2, or f of t plus t naught by 2 is equal to minus f of t. So what is happening in the first half cycle, that is from 0 to t naught by 2, will happen in the negative way. That is, the values of the signal from 0 to t naught by 2 will have negative values from t naught by 2 to t naught. That's all. So whatever positive values, whatever values it's having from 0 to t naught by 2 will have its negative values from t naught by 2 to t naught in the or in the next half cycle. Okay, so this things is particularly happening in our electrical machinery. That is, when stator is excited, the rotor conductors move or rotate, and the rotor conductors will interchangeably or they will come under the influence of north pole and south pole when they rotate. So when they come under the north pole, the rotor current will be a different have one direction, and when the conductors come under the influence of south pole, and then the current through the conductors will have the opposite direction. So these types of waveforms are found in electrical machineries. Okay, so here also, what should we calculate a naught, an, and bn? Here we have to go a little bit into the matter or into the subject, and so that we can understand clearly what is happening with a naught, an, and bn. An, of course, you can say it as 0. Why? Because the positive half cycle, exactly the negative of that is happening in the next half cycle. So when you take the average value of the whole cycle, that becomes 0. So the average value becomes 0. Okay, so a naught is equal to 0. So that is all over with a naught. And what is an? So we know by definition it is 2 by t naught, any integration over a complete time period, f of t cos n omega naught t dt. So here, for the convenience, I'm taking integration from 0 to t naught, 0 to t naught. Okay, so I split the integration just like the previous explanation. I split the integration into two halves. That is, since I'm considering from 0 to t naught, I'm splitting the integration, one from 0 to t naught by 2, that is I1, and the other, that is I2, from t naught by 2 to t naught. Okay, so here I make a substitution, that is, similarly x is equal to t minus t naught by 2. Simply I make x is equal to t minus t naught by 2. I take the integration I2. Okay, so integration is I2 is from, so when I substitute replace all t terms by x terms, then I should replace everything, or the limits of integration, all the terms, everything by in terms of x. So when x is equal to t minus t naught by 2, then dx is equal to dt. Okay, so simply you can replace dt by dx. Now what about the limits? Initially the limits was for t is equal to t naught by 2. For t is equal to t naught by 2, x is equal to 0. So my lower limit is 0. When t is equal to t naught, t naught minus t naught by 2 is nothing but t naught. T naught by 2. So the upper limit is t naught by 2. So the limits has changed from 0 to t naught by 2. Then instead of f of t, I can substitute what? From that, x is equal to t minus t naught by 2 relationship, we know what is t. T is equal to x plus t naught by 2. So I can substitute f of x plus t naught by 2 cos n omega naught. Then instead of t, again I can substitute x plus t naught by 2. Instead of dt, I can substitute dx. Now by virtue of the of this characteristics of the signal, that is, f of t plus t naught by 2 is equal to minus f of t, I can substitute, instead of f of x plus t naught by 2, I can substitute it as minus f of x. So minus f of x cos n, I can open those things, that is, things inside that bracket, that is n omega naught x plus n pi dx. Okay, now what is n pi? Sorry, what is n omega naught x? Okay, so n omega naught is nothing but 1 minute. N omega naught x. Okay, so n omega is nothing but 2 omega is nothing but uh, okay, I made a wrong thing here. That is n omega naught x plus n omega naught t naught by okay. When I open, what is that? Okay, that is right. So when I open, that is n omega naught x plus n omega naught t naught by 2. That is what we get. So what is n omega naught t naught by 2? I have shown that in the in the little bit higher side, on the side, that is n omega naught t naught by 2 is nothing but instead of omega naught I can substitute 2 pi by t naught, and so multiplied by t naught by 2, t naught and t naught gets cancelled, 2 and 2 gets cancelled, what is remaining is n pi. So I can substitute that. So that becomes integration from 0 to t naught by 2 minus f of x cos n omega naught x, that remain the same. Instead of n omega naught t naught by 2, I can substitute simply as n pi dx. Okay, so then this is a definite integral. I can simply replace that integration variable by x by t. So replacing everything. So this becomes minus integration from 0 to t naught by 2 f of t cos n omega naught t plus n pi dt. Now, what happens when n is even and when n is odd? We should consider that in two different ways. So what first we'll consider what happens when n is even. So what happens when n is even? When n is even, that is 0, 2 pi, 4 pi. So cos n omega naught t plus 2 pi, 4 pi, 0, everything will be what? The same thing itself. That is cos n omega naught itself. That is outside you have a minus sign. So that will remain as what? So the integration will, when you multiply, when n is even, the integration will be minus 0 to t naught by 2 f of t cos n omega naught t dt. Okay, so that means we have started with I2. So the integration is nothing but I1. Outside you have a minus sign. So that is why we have minus I1 when n is even. Now, what happens when n is odd? That is when cosine of an angle, that is cos n omega naught t plus, when you add that angle with multiples of odd multiples of pi, that is on n omega naught t plus pi plus 3 pi plus 5 pi, everything like that, then what happens? That is equal to the integration, that is a minus sign will be coming outside. That is, it will be minus that a minus sign will be coming outside. So already you have a minus sign. So what happens? That minus sign and minus sign will get cancelled. So the integration will be 0 to t naught by 2 f of t cos n omega naught t. Okay, so that means it is the same integration as I1. So when n is even, that is minus I1. When n is odd, it is I1. Okay, so what happens for an? So an means this whole integrations, that is an is nothing but 2 by t naught, the whole bracket. We have two integration, that is I1 plus the second integration I2. Okay, so when n is even, what happens inside? When n is even, I2 becomes what? Minus I1. Okay, so I1 minus I1 is nothing but 0. So when n is even, an is equal to 0. Okay, now what happens when n is odd? That is I2 is equal to I1 itself. So inside you have 2 I1. Sorry, inside you have 2 I1. What is I1? That is integration from 0 to t naught by 2 f of t cos n omega naught t dt. That is I1. So inside you have 2 I1. So, and we have just explained what is I1. So that 2 will be coming outside. Already you have having a 2 outside. So it becomes 4 t naught integration from 0 to t naught by 2 f of t cos n omega naught t dt. That is when n is odd. So can say that if we have a half-wave symmetry like that, that all even order harmonics are 0. That is the DC value is 0. Then the 2 times the fundamental frequency is 0. 4 times the fundamental frequency is 0. 6 times the fundamental frequency is 0. So every even multiples are even order harmonics are 0. And that is why in the crux of the conclusion or the crux of the discussion is that is why in all electrical systems you don't have even order harmonics. In all electrical systems, even order harmonics are absent. Why? Because of this half wave symmetry. I hope it is very clear. And similarly, you can have the other half wave symmetry also, that is the fourth type, that is instead of f of t is equal to minus f of t plus t naught by 2, you have f of t is equal to f of t plus t naught by 2. So, or what is happening in in 0 to t naught by 2 will happen in the next half cycle also, that is from 0 to t naught by 2 to t naught. Obviously, uh, here you can tell that the time period, already we have defined what is time period. Time period is the lowest time for which the pattern repeats, or for which the uh, the 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 periodicity, the periodic definition for periodicity is accepted. And here from this figure you can tell that t naught by 2 is the pattern which recurs again and again. So t naught by 2 is the time period of the signal. Okay, so if t naught by 2, if the time period becomes half, then the frequency doubles. That is what. So you can actually conclude that here the frequencies present are even order frequencies. That is the zero frequency is there, that is a DC value is present. Obviously, when you take the average, you will get a DC value. That is why DC frequency or DC value is present. And then 2 times f naught is present, 4 times f naught is present, 6 times f naught is present. Or you can prove in a similar way that we have discussed in the third half wave symmetry. And you can prove that in this symmetry, all odd order harmonics are absent. Only even order harmonics are present. That is A naught is present. Then all even terms of AN, that is A2, then A4, A6, all even terms are present. Likewise, then all even Bn terms are present. That is B2, B4, B6, everything are present. So in this, the fourth symmetry, all odd order harmonics are present and only even order harmonics are absent. So these are the 4 symmetry conditions you will be encountering shortly in all the problems. And I'll be working out 4 different types of problems so that you can understand what I have discussed so far in the 2 videos. Thank you.